Okay, so deep learning, you hear this term everywhere. It's powering the tech in your phone, it's at the cutting edge of science. I mean, it is changing our world at an absolutely incredible pace. But how does it actually work? Let's dig in.
Right. We've all heard the buzzword, but what's really going on under the hood? In the next few minutes, we are going to pull back that curtain and really get a solid, clear understanding of what this revolutionary technology is all about.
So here's our game plan. We're going to start by figuring out where deep learning fits into the whole AI universe. Then we'll get into the nitty-gritty of what actually makes it deep. We'll look at why it's absolutely exploding right now, see all the places it's already showing up in your day-to-day life, and then we'll wrap up by talking about its single biggest challenge, the black box problem. All right, first things first. Let's get our bearings because it's super easy to get all these terms jumbled up. But trust me, they fit together in a really simple, logical way. The best way to think about it is like a set of those Russian nesting dolls. The biggest, outermost doll is artificial intelligence, or AI. That's the whole broad idea of making machines smart. Now, open that doll, and inside you find machine learning. This is a specific way of achieving AI, where instead of writing a million lines of rules, you just show the computer a ton of examples and let it learn for itself. And then, inside that one, you get the smallest doll, deep learning. It's a very specialized and incredibly powerful type of machine learning. So that leads us to the big question, right? What is the secret sauce here? What does deep even mean in this context? Is it profound? Well, at its core, deep learning uses something called a neural network, which is a structure that's actually inspired by the human brain. The whole idea is to pass information through multiple layers. Each layer takes what the one before it figured out and uses it to find slightly more complex, higher-level patterns, building up a complete picture piece by piece. And this is a really important point, because a lot of people get this wrong. Deep isn't some metaphor for, deep thoughts. It's a literal description of the architecture. A deep learning model is deep because it has a deep stack of these layers, way more than the handful you'd find in older networks. Let's make this real. Imagine you show the network a picture of a face, the very first layer, the input layer. It doesn't see a face at all. It just sees a bunch of pixels. Its only job is to find the most basic things, like little lines, edges, or patches of color. The next layer takes those simple edges and learns how to combine them into more complex shapes, like the curve of an eyebrow or the circle of an eye. This keeps going, layer after layer, each one building on the last until a final layer can look at the whole assembly and say with confidence, "Yep, that's a face." And this is the absolute game changer. It's superpower, really. See, with older machine learning, a human programmer had to sit there and basically handcraft the features. They had to tell the computer, hey, look for two circles next to a triangle shape. With deep learning, you don't do any of that. The network figures out the most important features all by itself, just by looking at the data. That automation is what makes it so incredibly powerful. Okay, but here's a question for you. A lot of these core ideas have been floating around since the 80s, some even earlier. So why the huge explosion now? Why did it take so long to take off? It was basically a perfect storm of two things coming together at the exact right time. First, data. The internet gave us these massive, massive data sets, billions of labeled images and texts to train these models on. And second, we finally got the hardware that could handle it. Specifically GPUs, graphics processing units, from the video game world, which just happen to be perfectly designed for the type of math these networks need to do. And you can see how it all unfolded right here. The basic ideas were there for decades, like early networks that could read handwritten zip codes. But the real Big Bang moment was in 2012. A deep learning model called AlexNet entered this huge image recognition contest and just destroyed the competition. I mean, it didn't just win, it won by a massive margin that nobody thought was possible. That's the moment everyone in the AI world snapped their heads around and realized, okay, the game has fundamentally changed. And just to give you a sense of the sheer scale of this change, get this. Between that 2012 AlexNet model and the 2017 AlphaZero system that mastered the game of Go, the amount of pure computing power used in these huge AI projects increased 300,000 times. That is the rocket fuel that has been powering this revolution. So this isn't just some abstract tag for labs and universities. No way. This stuff is already all around you, completely woven into the fabric of your daily life. Think about it. Every single time you talk to Siri or Alexa, that's deep learning turning your voice into commands. When Google Translate instantly converts a foreign language for you, or your phone unlocks just by seeing your face. Yep, deep learning again. It's the engine behind your Netflix recommendations, the fraud alerts from your bank, and it's doing incredible work in everything from discovering new drugs to developing self-driving cars. And you can actually see the impact in the data. It is dramatic. Just look at speech recognition. For years and years, progress was just inching along, with error rates stubbornly stuck over 20%. But then deep learning models were applied, and boom, the error rate just plummeted. That's the kind of massive leap in performance we're talking about, and it's happened across dozens of different fields.
But, and this is a really big but, for all its incredible power, deep learning has this one kind of unsettling problem right at its core.
It's what we call the black box problem. See, because these networks basically teach themselves, the internal logic they build across millions of connections can be completely baffling to us humans. We can see the data that goes in, and we can see the correct answer that comes out, but the reasoning that happens in between, it's often a total mystery. So, for instance, you can feed a model a picture of a cat, and it comes back and says, I am 98% sure that's a cat. Great! But if you then ask it, okay, but why? What combination of whiskers and fur and ears made you say that? Well, we often just can't get a straight answer. The logic is just spread out across that massive, tangled web of hidden layers. And this isn't just some philosophical debate, right? It has very real kind of scary consequences. It leaves these systems open to what are called adversarial attacks. Researchers have shown you can take a picture of a panda, change a few pixels in a way that is totally invisible to the human eye, and suddenly a top-of-the-line AI model will confidently say it's looking at a gibbon. It shows that their understanding of the world is very different and sometimes much more fragile than our own. And so that leaves us with the critical question for the future, doesn't it? As we start to hand over more and more important decisions to these incredibly powerful but also incredibly opaque systems, things like medical diagnoses or even driving our cars, how do we make sure that we can actually trust their judgment? Solving that black box problem, that's the next great challenge in the story of deep learning.